When it comes to assembly lines, there's a little bit of some complexity to their logic. You gotta have all the items in the right order, you gotta have the fluids separated, and generally it doesn't play super well with AE patterns. However, in this setup here, I'm going to show you something that not only requires simply an AE pattern to be made to add a new recipe, but allows you to add more assembly lines in parallel by simply adding things onto these SFM variables. You need to make no extra commands, nothing else needs to be done here. Simply add them to 3 of your variables and all of your new assembly lines will work flawlessly. The idea behind this mechanic is using counting within these for loops, which allows us to do some tricky shenanigans that can essentially dictate a position within that loop. So here you'll see that we have a loop that loops through our buses. In this case, these drawers are our pretend buses, but it will loop through all of the first buses of each assembly line, find the first empty one, store that position over here, then start looping through the fluid inventories while recalling which position of the loop is the assembly line that is empty. If I want to show a little bit of this, by no means is this clean. I felt like I didn't really want to use any groups to just kind of keep it all displayed here. A little bit of this is extra. This stuff up here is just to handle getting the stuff out of the drawers. But generally, this over here is our main pushing mechanism. We have a for loop at the beginning, loops through our AE chests, and basically just checks, hey, are they empty? In case they find items, it'll then start looping through our first buses. That's just going to be your first item bus. You'll see here I have drawers, just a little easier than setting up 10 assembly lines just for a test here, but it's essentially the same idea. This would just be 16 long, and there would be 4 of these here instead of 2. These are emulating our input buses, and these here are emulating the fluid hatches. So once we find that full chest has a recipe in it, we start looping through those first buses. Here I just have a shutoff that checks if that AE chest is still full. This is basically just to stop some of this excessive looping once it's moved the recipe. You'll see we have an input here. This is where we start doing the counting. So I input from this drawer I call C0. That's this one over here. It stores a block I've labeled as counting, and it will use that to dictate where in the loop we are. We will see I then output to C1, but the interesting part is we're actually moving 4 items at a time. The reason for that is because we have 4 of these blocks here that we are iterating through. So the idea is that we will loop our first buses to find the first empty assembly line, but then once we start pushing the items to them, we'll need to be able to use that value and take an increment out of that value that will correlate to a whole assembly line. Sounds a little complicated, but basically the idea is when you check the bus is linked to this whole set of 4 drawers, so it moves 4 items at a time. Then on the second loop you check this one, which is linked to these 4, moves another 4. At that point you've moved to 8, because coincidentally enough we have 8 total inventories. After that, we have this little check, which is going to see if the bus is actually empty. On the case that it is empty, which is the false here, we're going to pull from that AE inventory, that fake one that we set up over here. In this case, I have it set to NBT independent for flasks. That's because this first part is going to be handling the fluids, second part will be handling the items. Now we're just going to iterate through our fluid tanks, and we're going to go up here and, sorry, not variable, we're actually going to check that counting drawer. However, we're specifically going to check for one item more than the amount of one assembly line. So normally for an assembly line you would have 16 inventories. So this over here would be pulling 16 blocks instead of 4. But because I have them kind of small for the testing purposes, it will pull 4, and this check up here will check for one more than that, which would be 5. If this returns a true, it means that we have yet to arrive at the assembly line that we want to push our items into. So what we're going to do is simply pull items out of our C1 counting drawer, and we will push them into our C2 counting drawer. Now you'll see here I'm pulling 2 items at a time. That's because we have the 2 fluid inputs per assembly line. So 2 times 2 is 4, which means once we've gone through 2 inventories, we will have used up all of the blocks for one assembly line. The other option here basically just says if there are 4 or less blocks here, but there still are blocks in that C1 drawer, that means we've actually reached the point where we want to start outputting, and that's where I have this output set to pink variable, which is our looped input hatch. Same idea goes for the item buses, except the input here is just blacklisted. We don't need to pull specifically any type of item. All the flasks are already gone. And the only difference is the input here is 1 instead of 2. That's because we will loop through, pull 1 per inventory slot. After 4 inventory slots, we have pulled 4, the amount that we pulled over here, and that signifies 1 whole machine. The only additional thing I have here is a small little input-output where I input from C2 and C1, and then I output to C0. This is just to handle the case in which all the machines are full and there's recipes in these chests waiting to be moved. Some shenanigans happen because it won't actually ever be able to count down. I have 3 quick little demonstrations to show the functionality of this. You'll see I do actually have a redstone condition here. Basically just whenever this lever is in the up position, it's going to pull the items out of the drawers. When it's in the down position, it'll run all the transfer code. I'm going to keep it up for now, and I can go ahead and queue up 4 of these fake assembly line recipes. You'll see each one has items and a fluid. We got 4 of them here. Now if I go ahead and I pull this lever, we should see that all 4 of them are going to be moved into these first 4 assembly lines all at once. Bam, just like that. They're all in there, all in the right order. If they had more items, they would be there, but I just have the one for the moment. If I were to now go ahead and queue up another recipe, we should see it enter the 5th assembly line. If I were to queue another one, bam, should be in the 6th one. Now if I get a little fancy with it and I pull these guys out, we should see that if I queue another one, it'll enter that 1st assembly line. Now, just to handle a little bit of the next example here, I'm going to go ahead and queue up 4 more things. The reason for that, out of CPUs. The reason I'm doing that is just to get them all filled up. We should now see that they all have a recipe in them. So this would be the case in which all of your assembly lines are running. Now if I go ahead and I queue 1 more, we will notice that it actually just stays right in that chest. Nothing happens, it doesn't end up anywhere else. If we look over here, all of our counting stuff is still very normal. However, it's just not moving the recipe because it's not finding an empty assembly line. Now, if I were to go ahead and let's just say plop these out, bam, we get that recipe right there. Now, I'm actually going to go ahead and disconnect this for now, and that's because I want to show how easy it is to add a new assembly line to this. I'm going to expand this out a little bit, just so I have some room. Find the end of the cable network. Now, of course, you would actually build whole multi-blocks on this. I'm simply doing these just for the demonstration, but the exact same idea would apply. Now I'm going to go ahead and label these guys as fluid drawers. I'm going to label these as item. This just lets me search them easier in the crafter. And then I'm going to label these guys as item first. These are simply just the ones that are going to dictate whether it's full or not. The rest of them are just for pushing purposes. Now if I go over here, I find my first bus. I can go ahead and type in first. We'll see that we have those two new ones. This one here is all the buses. I call it item. And then here we have all of the fluids that I labeled as fluid. Select all. Now it's actually just as easy as that. If I now go ahead and connect this up here, I'm actually going to go ahead real quick and queue 2 recipes just so they are in the chests all ready to go. We got the 2 right there. 2 free assembly lines. Now if I go ahead and I connect this to this, bam, items moved. Look at that. Right spots, perfect. Nothing else needed to be done. The counting method is entirely unrelated to the quantity of the assembly lines. It is abstracted to the point in which you don't need to edit the commands at all. You really just need to add them to these 3 variables. If I wanted to get a little fancier, I could also go ahead, throw those guys in there, pull this out, and if I wanted to add a new AE input, I could just throw that guy on there, and bam, what I just put in here is now in this. Very easy to add new things, very expandable, very easy to copy and paste as well because the majority of these are just using internal values. You really would just need to add things to this and then go ahead and define your counting drawers. So I figured I might as well throw in one real test for this, showing it with some actual machines. So I have 4 fully built assembly lines here, basically running the same idea of the code. I have something that does the whole search for the first open inventory slot. Then we have these which are a little bit different, actually have a slightly different counting system. Basically the idea is in this scenario I use drawers as initial input, so you can shove essentially an unlimited amount of an item in there. Basically just increases the amount of parallel recipes you can push at a time. And what I do is then shove those into the bus that's right above there. But the problem is if you do that, you have issues where like sometimes the drawer will have items or sometimes the bus will. And you need a way to basically like link those together. So I just have something here that will count basically like every other time the loop runs, and it'll store what the first run received. So basically this is the first thing that it'll do, checks whatever thing we're looping, and says like, hey, does it have any items? And then if it does, we push it to this drawer. If it doesn't, we push it to this drawer. Then it runs a second time, checks, sees that one of these drawers has an item in it, meaning it's already ran once. Then it empties that drawer, pushes it back there, I believe. Oh no, sorry. This is where it actually counts. So we do 16. And then up here is where I believe we do the whole part where it checks, is that bus full? If it is, nothing matters because I'm going to skip it anyway, but if it isn't, we check if the other inventory was full. Same idea, just a little bit split because we now have the two things we have to check. Then I have this, which leads us over to our move function. Same idea, filter for those flasks, push them in, count down. In this case, I believe we're counting down by 4s. Numbers we check for are 17 and anything. And same idea for the items, except, you know, instead of counting down by 4, we just count down by 1. But once again, we do still check for 17. So if I want to go ahead and queue up a recipe, I'm going to queue up decent amount of some UV motors, some oh, shit, we're actually running out of items. Alright, now if I craft all these up, you'll see I threw activity detectors with redstone lamps above them, and there's a little bit of flickering. That's for a reason that I can still work out, but for this setup doesn't really matter. But you'll see for the most part they are always on. Look at a recipe. This is how I set up the UV motor using these gigantic flasks for the item or the fluid inputs, and then I named all of the differing like the same type of items, so they won't stack when it pushes them into these chests. Then I pulled the old make a whole bunch of recipes, increase the parallel, and we should start to see all of these items coming in. So yeah, I hope that this helped explain my slightly strange idea for an assembly line setup, but as you'll see, it does actually work. If I wanted to, I could just go ahead and add more and more and more on here. Doesn't take any SFM definition, works very well with these, it works in parallel, works pretty quick. Now, this is probably not the most optimal setup that you can make. I'm sure there are Open Computers alternatives, even probably SFM alternatives that are better, but this is pretty simple to set up, very expandable, and overall definitely something that I would be using in my assembly lines when I really don't want to be defining as much specific things as you sometimes need to. Now, if anyone does go ahead and make something like this, I would like to know how it turns out. I haven't actually used it in a real world. I've just done the tests on it, so maybe there's some TPS issues I'm unaware of, maybe something else. However, from everything I can tell, this does seem to be a pretty solid method of tackling the logistics of these very strange machines.